I passed. But anyway, this is just kind of the tip of the iceberg, getting into probability. All right, so we're going to start off with a pretty basic example. So here, let's say you're looking to buy a shirt. So with the shirt, there are 4 different shirts that you like, and each one comes in 3 different colors: red, green, and blue. So the question is, how many possibilities of shirts do you have? If you know the answer, feel free to type it in, but I'm going to explain the logic here. So explain how we can figure this out. So if you had to list out all the different possibilities, you would realize that for the first shirt, so shirt number 1, we have 3 different options. So for shirt 1, we have red, green, and blue. So the 1 means shirt 1. We have red, green, and blue as different options. For shirt 2, we have the same options: red, green, and blue. For shirt 3, we have the options of red, green, and blue. And for shirt 4, we also have the options of red, green, and blue. So we could count all these up: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, to get 12 total possibilities, 12 total different types of shirts that you could purchase. Okay, so we could count them up like that, but this fundamental principle of counting is going to help us where we don't have to actually count every single option. We can use a little process of basically just multiplying the numbers together. So if we have 3 options, so 3 colors, and for each color we have 4 different shirts, if we multiply the 3 times 4, or 4 times 3, we're going to get 12 possibilities. So that is illustrating the fundamental principle of counting, or the fundamental counting principle. So what that says in math notation says if one selection can be made in m ways. So in the last example, we had 4 different shirts, so we had 4 different ways we can make the first selection. And then for each of these, a second selection can be made in n ways. So n in the last example was 3, because we had 3 colors. Then you multiply those 2 numbers, m times n. So in the last example, it was 4 times 3. Okay? So bottom line, you're just multiplying the numbers together. All right, so class will give you another example. Let's say that you are making a sandwich. So with your sandwich, you have 3 different types of bread. Maybe you're making a sub. You have 3 types of bread. You have, let's say, 2 types of cheese to choose from. And let's say you have 4 types of meat. And the question is, if you're going to use one of each, a bread, a cheese, and a meat, how many different types of sandwiches could you create? So if you know the answer, please type it in. This is your example problem. Okay, so I see Cheyenne, I see Kai, I see Isabel, Joy, Brandon. Everyone's saying 24. So do you guys agree with them? Kaden agrees. All right. Yes, I would also agree. Very good. Because we have 3 options for the types of bread, and for each type of bread we have 2 options for the types of cheese, and for each of those options we have 4 types of meat. So the fundamental counting principle says we just multiply these different options together to get your total number of options to get 24. So we have 24 different options. All right. Can you just check in quick before moving on? Can you give me a quick 1 to 10 how we doing? And are there questions so far? All right, looks like we're doing pretty well from those responding. All right, so that's pretty much the main concept of the lesson. We have some different example problems to go through. So I have 2 more for the lesson, 2 more examples. It looks like we're doing well with the basic understanding of the principle. All right, so here, same kind of idea. Okay, it says here, how many odd 2-digit positive integers greater than 30 are there? So again, we could, just list out every single possibility. So it's got to be odd, 2-digit, and greater than 30. So if you list them all out, you'd have 31, 33, 35, 37, 39, and do that again for the 40s. You have 41, 43. notice it's going to take a very long time, right? You have 40, 50, 60, 70, 80, 90. Okay, it's going to take a long time to do. So again, we can use our fundamental principle of counting to determine the total number of choices. All right, so realize a 2-digit number would have a tens place and a ones place. So it could be 31 or 40 something or 50. So it's got a tens and a ones place. So class, can you tell me how many options would you have for the tens place? It's got to be greater than 30 and it's got to be odd and 2-digit. How many options would you have for the tens place? Okay, I see Kai, I see Joy, I see Isabel. So Miles, I thought your name was Pi for a minute, and I realized it was just some random 345, 345. All right, I see a lot of sevens. Okay, do you guys agree with the sevens? 99, I'll tell you, is way too big. It's not 99. For the tens place, as you're thinking through, and as we're seeing if you guys are correct, you have to think through what tens place options do we have. So it could be 30 something, it could be 40 something, it could be 50 something, it could be 60, 70, 80, or 90 something. So if you count out all those options, you have 30s, 40s, 50s, 60s, 70s, 80s, 90s. That's 7 different options for that tens place. Does that make sense? Can you guys give me 1 to 10 on that, where that 7 came from? You understanding? Because I know sometimes this confuses people. I want to make sure I'm not losing you before I move on. So you understand where the 7 comes from? You have 30s, so the tens place could be a 3, a 4, a 5, a 6, a 7, 8, or 9. This could be 30, 40, 50, 60, 70, 80, 90. Now if you hit 100, it's too big, right? It's got to be 2-digit, so it can't be 100. All right, so I think we're doing okay. All right, now for the ones place. How many options do we have for the ones place? So if you can let me know that. Okay, I'm seeing a few responses. I see a 7, I see some 5s. So for the ones place, we'll see who's correct here. The ones place, that is limited by the fact that it's odd, right? It's an odd number. So the ones place needs to be an odd number as well, because the last digit makes your entire thing odd or even. So like you can have the longest number in the world. You could have 5,327, which is not the longest number in the world, but you can have a big number, and the whole thing, to determine if it's odd or even, you just look at this last digit, the ones place, right? So the ones place is what determines odd or even. So to make it odd, this last digit must be an odd number. So it must be either 1, 3, 5, 7, or 9. So if you count those up, 1, 3, 5, 7, 9, those odd digits, that gives you 5 options. Then you multiply those together, 7 times 5 is 35. All right, can you check in again? Give me a 1 to 10 how we doing on that. And are there questions on that? And by the way, good job to those that got that correct. So Joy, you're saying what? Okay. The ones place. Do you understand the fact that if you have a number like 5,327 or 126,193, to make the entire number odd, the last digit must be odd. Does that make sense? So the last digit would have to be a 3, 7, could be 1, 5, 9. So the only odd digits we have that the last number could be, the ones place could be, would be a 1, 3, 5, 7, or 9. That's the only thing that could go here for the ones place. If it was something different, like a 2, that's not odd anymore. It's got to be, it'll make it even. So it's got to be one of these 5 options for that last digit. Does that make sense? We see that here in this this first column, where we're kind of like just listing out the different options. We have the ones place could only be a 1, 3, 5, 7, 9. For the 40s, it could be a 1, 3, 5, 7, 9. 1, 3, 5, 7. The last digit must be an odd number. So the tens place, is because it says it's greater than 30. Greater than 30. So the tens place, okay, thinking through your options, if it's greater than 30, you could have numbers like 31, 33, etc. Okay, you could have 41, 43, etc. 51, etc. 61, could be 71, 81, 91. So that the tens place could be a 3, 4, 5, 6, 7, 8, or 9. It can't be a 2. If a 2 is in the first one, that makes it less than 30, right? If you have a 21, 23, 25, so it can't be a 2 in the front. And it cannot be anything bigger than 9, because if you put like 10, it's like 10 and then a 1, or 10 then a 3. Now it's not 2-digit anymore. So it has to be numbers between 3 to 9. So 3, 4, 5, 6, 7, 8, 9 are the only options for the tens place. So that gives you 7 options. Okay, hopefully that made a little more sense. Let's try another example. This is the last example I have for the lesson. If you need extra, we could do more. We got some more in the game as well. All right, class, how many odd 3-digit positive integers can be written using the digits 1, 4, 5, and 6? So I'll let you guys maybe try this one on your own, see how you do. Give you a little head start. So I know based off teaching this in the past, this can be difficult maybe to process sometimes, so I'm not expecting everyone to get this on the first try by themselves, but do what you can. We'll walk you through here in about 30 seconds. Okay, see Miles, you're a little lost. We'll explain here in a moment. Let everyone else try it for a little bit. Okay, give you guys a little head start. So if you're still working, keep on working. So I don't have the answer in front of me at the moment, so we'll see here if we got it correct. So let's kind of walk you through. So we have 3 digits. So 3 digits. So we have a hundreds place, tens place, and ones place. That's a 3-digit number. All right, so you've taken care of that. It's got to be odd. It's got to be using the digits 1, 4, 5, and 6. All right, so all right, so for the odd part, what number is being affected by the odd part? Is it the hundreds place, the tens place, or the ones place? Which number affects the odd or evenness of a number? Okay, Isabel says the ones place. Do you guys agree with her? Okay, Cheyenne agrees, Kai agrees. Yeah, I would also agree. Very good. Because we mentioned that in the last problem, right? The ones place is what tells if it's odd or even. It could be a large number, but that ones place, the last digit, is what affects odd or even. So here, the ones place must be an odd number. So how many odd digits do we have to choose from? Well, we're limited even further because we can only use the digits 1, 4, 5, and 6. So from those options we have to choose from, how many of those are odd that could be in the ones place? Yeah, good. The only odd digits we can use are the 1 and the 5. So we can only use one of those 4 numbers. Those are the only 2 that are odd. So the ones place has 2 options, the 1 and the 5. Okay, are we good so far? Any questions so far? So we've taken care of the oddness. So really there's no other limitations for the hundreds and the tens place other than the fact that we have to use one of these 4 digits. All right, so for the hundreds place, how many options do we have for the hundreds place? Well, we have to use one of these 4 numbers. There's no limitations, doesn't say anything about being, greater than a certain thing or less than a certain number. So it's just one of these 4 numbers. So we have 4 options for that hundreds place. Then how many options for the tens place, class? There we go. Very good. So we only have 4 options again, because we can only use these 4 digits, right? There's no limitations on the tens place. So it's 4 options for that. So we have 4 options for the hundreds place, 4 options for the tens place, 2 options for the ones place. You multiply that all together, 4 times 4 times 2, to get 32 possibilities. All right, and that's your answer, 32. Okay, can you guys check in? Give me a 1 to 10. How are we doing? And are there any questions on this example? So I know it's one thing to see the teacher do it and to understand. That's another thing to get it completely by yourself. So this will come with practice. So at this time, we'll get some more practice with the game. The game gives you, I think, one like this, and we have some other types and some different types of examples you'll see. So at this time, let's head over to the game. We'll get a little more practice, and I'll be right with you. The pin is right here. We got 398100. Is anyone not joining us for the game today? We're doing really good on time, so if you can, I'd like you to stick around for a little bit. We'll try to keep it 10 minutes or less normally. Okay, so we got 2 people in the game. Our total is 9. So waiting for a few more. So wait, Joy, what's up with the U in your name? Because it was in your username in Click Meeting and also in Kahoot. I'm curious if the U stands for something. Okay, and you're being consistent now in the Kahoot game? Is that what you're doing? Okay, it's not working for Caden. Okay, I'll wait a few moments here. So if you're gonna play, we're gonna start in about 20 seconds. If you try to get in within the next 20 seconds or so. But use your Chinese surname. Interesting. Huh. Because I forget, are you part Chinese? Or do you just enjoy the Chinese culture? Okay. Who else is playing? There's only 4 in the game. We got like 9 total. Kind of a small crowd today. Okay, we're gonna start in 10 seconds, all right? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, I guess just 5 people. Hopefully, maybe another person or 2 joins us. So we only have 5 questions total. So 5 questions, here we go. So how many possibilities if you have 4 shirts, 2 pants, and 2 shoes? There we go. So possibilities you find by multiplying the different options together. 4 times 2 times 2 to get 16 total. All right, we're going to see a few different types of examples, so make sure you read carefully. How many possibilities? You choose a number from 1 to 10, followed by rolling a die. Die is singular for dice, by the way. So you roll a dice or die. So how many possibilities? There we go. Okay, you guys caught on pretty quick. So number from 1 to 10, that gives you 10 options for the first part. And then when you roll a die, or dice, that's plural, there are 6 options on a die, right? So you have 10 from 1 to 10, and then 6 options for a die. 10 times 6 would be 60. All right, very good. Got Isabel, Cheyenne, and Kai, and then Joy in fourth. All right, next question. Here we go. How many possibilities? Choosing a number from 1 to 10, followed by flipping a coin. Wow, okay. Yep, so very good. I'm going to assume you are understanding if everyone gets it correct. So awesome. Okay, so we got Cheyenne, Isabel, Kai, and then Joy. Okay, next question. How many possibilities? Choose a letter from the alphabet, followed by choosing a digit 0 through 9. I'm expecting some people to get tripped up on this one. I'll see if you can get it. All right, I was afraid of this. So there's 26 letters in the alphabet, okay? And then digits 0 through 9. That would actually be 10 options, right? If you count those up, 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 different options. So that's 10 times 26 letters in the alphabet. 10 times 26 is 260. That makes sense? So if you put yellow, I believe that's 26 times 9. That's actually 26 times 10. All right, so we got Kai taking the lead, first place, Cheyenne in second, Isabel third, and then Joy in fourth. All right, last question already. So here we go, last one. 10 names are in a hat and 3 names are drawn without replacing. How many ways are there to draw? This one I gave you guys a minute to do. Hey, pretty good. So 2 of you guys got it. This one I'll explain over here on this PowerPoint. Let's delete these. Oops. Okay. Give me 1 sec. Okay, so it's the idea of a raffle kind of idea. So if your name's in a hat, there's 10 different names total. So we're gonna draw three different raffle tickets. Okay. So for the first draw, okay, if there's 10 possibilities, 10 different names, okay, we have 10 names that are possible for the first draw. So once you take one out, okay, how many options are remaining once you take one out? That's going to be 9, right? So once you draw a name out, there's only 9 names left in there for draw number 2. And then once you take 2 out for the third draw, there's only 8 numbers remaining. So this is the numbers you're multiplying together. 10 times 9 times 8. That gives you 90 times 8, which would be 720. So there's 720 ways that you could draw 3 names if you have 10 names to begin with. All right. And our final score, Isabel coming up in first. Good job, Isabel. And then Cheyenne only 25 points behind, second place. And then Kai only 10 points behind Cheyenne in third place. So very close scores. And then Joy in fourth place. So good job to Joy as well. So good work today. That does conclude our class time. So for those heading out, you're free to go. So I hope you have a great weekend. Before I leave, are there any questions for anyone? Anyone need help with anything?